Other comparisons. Instructions. So set less than immediate. Check the content of one register and immediate data. If this one is less than this immediate data, then this register will be set to 1. Otherwise this register set to 0. So this one is an example. You can change it to any other registers set less than unsigned and set less than immediate unsigned. The content of one register can be interpreted as signed or unsigned value. For example, when you want to compare two values, I see that these are my values. 0x. Pool. Is it less than? Which one is going to assume that this is true and this is true? I want to compare them. And according to the results of this competition, I want to set a register to 1 or 0. Is register 2 is less than register 3 or not? As I mentioned, this number can be interpreted as signed or unsigned, unsigned number. This is 65,535 and of course, 2 is less than 65,000. But if I assume that this number has the assigned value, it will be -1. So 2 is greater than -1. So both of them are correct. So which one should be considered by the CPU? The type of the instruction will determine this problem. That's less than online. Consider register 3R's 65,535, but less than consider it as a -1. This is for science value. This is for unsigned value. This is for immediate data science value. And this is for immediate data on-site value. So we have two different instructions for signed and unsigned comparison. So if I write SNT set less than, for example, just sign 1, then I sign 2, and then I say 3. Or write it in this way. If I said sign on, sign and I signed 1, then I sent 2 or 3 for the first one. We just want 2. These two register 3 is -1 and 2 is not less than 3, so it will be 0. But for this point, register 3. Consider 65,535. 2, of course, is less than this number for this one register. 1 will be set to 1, so the result of the set will be 0 or 1. After that you can check the register with 0 register in order to find out that is it set or not. My branch equal color sign $1 sign 0. And the label that you want to go. OK. Similar to this statement. So this type of conditional expression in high-level language will be converted into two statements. In MIPS assembly language. These are the jumps and branches instructions in MIPS. Let's see which form is covered at this point. Jump and label unconditional jump. Jump register will jump to the office that is inside this register. Use a register as the Optimus actually and jump to the content of this register. We will find out what is the purpose of this instruction. It will be very useful for returning a selection in procedural programming. Jump, and this is exactly the way that we call a procedure in MIPS and jump on the register. I will talk about that in another lecture. Branch. Branch not equal. There are some other type of branches. We only cover these two ones, but there are other types of branches ranked less than or equal to 0. Branch greater than 0 and branch greater or equal to 0. As you can see in all of them, we only check it with 0. Less than 0 greater than 0 greater than equals 0 less than or equals 0. Only this type of the condition. So we have two operands. But if you want to compare it, for example, greater than 10, you have to split it into several needs assembly. So as you can see, there was more branch less than in a section for comparing two registers. One of the reason is that such an instruction would be too complicated and would force longer cycle time. Therefore, conditionals that are not comparing against 0 take at least two instructions where the first is a set and the second one is a conditional branch. But MIPS assembler supports some type of the signaling instructions that can help you to write code easier, and assembler will convert your code automatically to the appropriate sequence of MIPS instruction. For example, you want to transfer the content of one register to another one. There isn't any instruction for this one in MIPS. For example, if I want to call it a copy after just the 2 and put it in register 1, I have to write it in this way. I was just there 2, with nothing. But just as 0 is 0. So this will be 0 plus register 2 or 3. The result will be registered 2, and the result will be save in register 1. So this line is the way that I have to copy the content of register 2 into register 1. But you can write it in this way in MIPS and the assembler will be converted students. This is a student structure. The student interaction will be converted into the equivalent MIPS assembly language. In this example, there is one line here and the pseudocode is one line, but the pseudocode is one line, but the equivalent MIPS will be more than one line. For example, greater jump list. These type of instructions are not really MIPS instructions. These are instructions and you can use them. Then the assembler converted into the equivalent set and branch that is necessary. Another instruction is load immediate. If you want to load an immediate data into the register, there isn't any instruction for this purpose. But it is a very common action that we need. We want to initialize the registers. In fact, in this way, it makes an immediate. They just got us on 0. And that immediate value that you want, and this is the target, which is the. So these two numbers will be at 0 plus immediate in the immediate value, this number will be more into the register, which is the destination in this example. But you can write it in this way. Also note immediate. For example, we want to compare the content of two registers and according to the result, I want to jump to the label less than equal, greater, or greater than equal. These are the instructions here. T0 and T1 should be checked and we want to branch to the 4 axes. If T0 is less than T1, so set less than 0 1 T1 will be checked and answer will be register AT. Another convenient name for registers. you will see it and then by branch not equal. The result of the previous statement will be checked with the 0 and the label that we want to go. So this is the instruction that you can use it in your core branch less than, but the assembler will be converted into the translated into the score. So these are not really MIPS instructions. You can use that branch less than or equal branch greater or equal to register will be compared. And we will jump to a specific later. These are mythological instructions or form and all. It's all over the content of two registers and the result will be a store in the destination, which is also no operation. If you are familiar with this Boolean operations from digital design course, but this time you perform the operation over to 32 bits number. Bit by bit they will be AND or X or not together and the result will be inside the destination. Just to give you an example for adding these two numbers, but assigned to have this number 57.8 in hexadecimal while R is a bit small and I ask you what will be the value of this statement. In order to compute it, you have to first convert them into the binary and then bit by bit you can perform and or other logical operations that are mentioned here, the result and convert it back into the hexadecimal. Now we can use this operations in order to cover some part of the data with 0 or 1. So that is my number. 1.11111 times 10 to the power of 11th. However, this part of the data with 0 and what I don't want to change the risk for other objects for this purpose you can end this number with 1.111 times 10 to the power of 14th. So if I end this two numbers, the red part will be covered with 0. We call it mask 0. If I OR them, then this part of the number will be masked with 1 and this part be the same as the original version. So masking by 0 or masking by 1. Or if I perform X or what will be the X or of these two numbers, 1 on 1 will be 0 0 0 0 here. 1 1 1 0 0 1 1 1. And here 0 1 1 1. What's happened? As you can see, the part that I put is complemented for this part is for beat and this for date they are complemented. This religious. But the red part, which is exported by 0, is the same as the original version. So by using export, I can complement a specific part of the number, a specific part of the data that I have in one register. And I can mask a specific part of the data with 0 or instruction. I can mask it with 1. So this is the example of an or its or instruction. For the immediate version, for immediate updating mode, we can perform this operation by the content of a register and constant immediate values that we mentioned here. So we have an immediate or immediate or immediate.